Okay, I'm going to get started now. So hi, my name
Instant.
is Monica Tang, and I'm an advisor for sector capability with the Save on Energy team. On behalf of Save on Energy, thank you for taking the next 60 to 90 minutes to join us in learning more about battery energy storage system safety for greenhouses. We heard from the market that there was a lot of concerns about the safety of batteries, so I'm excited to share our panel of expert speakers from the IESO, University of Windsor, Save on Energy, Energy Storage Canada, Electrical Safety Authority, Underwriter Laboratories, and the Ontario Ministry of Job Creation, Economic Development, and Trade. Megan, can you go to the next slide, please? Thank you. So for our agenda, we're going to be talking about the regional planning in Southwest Ontario, the Grid Innovation Study findings, Save on Energy distributed energy resources incentives, safety considerations for BESS, safety codes and standards for BESS, safety regulations for BESS, and behind the meter energy storage case studies in Ontario. I'm going to pass it over to Candida. Oops, sorry.
We actually have a quick poll to go through before we get into the presentation. So there's a little raise your hand feature at the top of Teams. And the first question we have, raise your hand if you have a cell phone or laptop in your home or workplace. Yeah, lots of hands coming up. Okay, lower your hands and raise again if you've got an electric vehicle or even a battery energy storage system at home or, again, at the workplace. Okay, a few more people that that's true for as well. Again, really quickly, some housekeeping items. I think most of our guests are here today. I'm going to be muting everyone. We have reserved some time for Q&A at the end of the session, and we have a great panel of speakers today. As we go through, please feel free to type your questions into the chat, and we will be addressing them all at the end. If you can, indicate which one of our guest speakers your question is for. That will help us manage the Q&A a little bit more smoothly. And with that, I will pass it off to Candida.
Thank you. Good afternoon, everyone. I am Candida DaCosta, the Senior Transmission Planner here at the IESO. I've been working primarily in Southwestern Ontario over the last few years. So I am currently leading the regional plan for Windsor-Essex, and I have also led some of the bulk plans for the Southwestern Ontario. So some of the recommendations that I'll talk about were a result of those plans. We get into the next slide. It's really just talking about what is driving electricity demand in Southwestern Ontario. And that there's really two main drivers that we're seeing in the area. So the first being vegetable greenhouse expansion. So with the shift to provide year-round local produce, there's been an increase in electricity demand resulting from the addition of agricultural lighting for indoor greenhouses. So that's one aspect. And then the second aspect is in terms of economic development. So that is anywhere from automotive manufacturing in the Windsor area, the expansion of EV manufacturing across Southwestern Ontario, and those big, larger industrial load development that we're seeing across Southwestern Ontario. So what we see on the right-hand side, is the forecast, the winter forecast for the Windsor-Essex region. So this is just one region within Southwestern Ontario, but it's been seeing increasingly significant demand due to those two drivers. So based on our reference forecast, we're expecting doubling of demand, winter demand by 2035. And then if we look at the high forecast, that gets to over 3 times higher by the end of our study period, which is typically 20 years out. Yeah, we can move on. So based on that kind of significant demand that we're expecting in southwestern Ontario, we have been seeing the need for electricity over the past few years. And that has resulted in basically continuous planning over the last 5 to 7 years, resulting in a multi-pronged approach. It was really just using every tool in our toolbox to be able to provide that additional capacity that we need for the area. So that's resulting in a number of transmission recommendations, some of which are already in service, some of which are under construction, and are expected to be in service between now and 2030. But we're also recommended local generation, as well as targeted energy efficiency programs and innovative projects, such as the one of the ones that we will be touching on later in this presentation. So one key takeaway that I wanted to highlight in the slide is that we are doing, we have forecasted growth in this area, and we have made a number of recommendations. And really the pinch point that we're seeing is that the transmission that we recommend takes a number of years to develop and implement. So if we're seeing growth in the next 3 to 5 years, the typical transmission development timelines are 5 to 7 or 7 to 10 years. So there is a bit of a gap between how quickly we can get transmission infrastructure in place compared to how quickly loads can grow. So what we are trying to do is balance the transmission recommendations with some of these energy efficiency programs and targeted projects, as well as generation, which can come in slightly faster in order to bridge that gap in the near term. Maybe we can move on to the next slide, which just goes a little bit deeper into some of those innovative solutions that have been put in place for Windsor-Essex. So we have invested over $1 million to test energy efficiency measures. So that's really just looking at the impact of using LEDs or artificial intelligence to kind of change the timing of and color of the lights that are used in order to help the agricultural industry have a better sense of the impact that might have on their crops and be a little bit more comfortable taking those more energy efficient measures. So the next step was also to commit over $65 million in incentives, so that once we tested it, you're kind of a little bit more familiar with the impacts. Then we provided funding to incent the installation of LEDs and grow lights in order to realize that energy savings. And those programs are in place, have been in place since the last regional plan, so for a couple of years, and are currently still underway. Maybe with that, I will hand it over to Ruth for the next, to go over the Grid Innovation Fund, one of those projects.
Thank you. It's very nice to be here. It's great to see what an enormous turnout we have. I'm largely here to basically relay some of the findings we had from a recent project we did for the Grid Innovation Fund. I'm a professor at the University of Windsor, and I'm the director of the Environmental Energy Institute. And if I can go to my next slide, I can discuss a little bit about our project that has relevance here today. So this project looked at what options we may have for distributed energy resource solutions for the greenhouse sector while transmission lines are being constructed. So the project had major funding from IESO, also contributions from OGVG, 360 Energy and Hydro One, as well as Undersun and Rising Sun Acres, some local growers. Next slide, please. So what the project did was it tried to look at, in great detail, loads from 5 what we consider to be representative growing operations. So we had 2 pepper operations, Both of those were not using grow lights. And then we had cucumbers and tomatoes and cucumbers, all of which were lit with HPS lighting. And you can sort of see in the graphic below that table the massive load that lighting, sort of imparts. And our growers who are present are acutely aware of this. And so, there are a lot of sort of, I guess, requirements in terms of getting the flexibility right to meet those loads. And so what we did was we said, well, if we have the following tools, if we can look at solar PV, renewable powered natural gas fired generation, and battery energy storage systems. So what sort of combinations of these can we put together to yield DER solutions that could help meet these loads? And so next slide, please. We went about it quite methodically so that we could feel sort of that there was detail and credibility in the space. And so we were very, very careful with the load depictions. And we went through how each particular greenhouse operated, its crop cycle, and then into how electricity was used to meet those operational requirements. We did a sort of detailed billing analysis, again, to help the stakeholders understand where the money is going. And of course, on the lighting side, looked at the lighting technology and how lighting was being used. Taking those inputs into account and the present day technology that was available, and granted, this was about 4 to 5 years ago, so we know how quickly this technology continues to evolve. We came up with 5 different designs for all 5 greenhouses. In addition to that, we looked at linking them all together in sort of a microgrid dynamic. But those are additional details. What I kind of wanted to talk a little bit more about today was really just the sort of the solar and battery side. So if we could go to the next slide. And again, these are high-level results, but if you sort of look at, again, these prices and these numbers are a bit old and would certainly benefit from some additional tightening up, and I would say present-day optimization. But the photovoltaic and battery solution for our first of 5 characteristic greenhouses yielded the most affordable sort of outcomes. And it is clear that on its own, batteries and solar aren't going to conquer the massive loads that come with some greenhouse grow lighting. But if you have an operation that isn't lit, you can, depending on the size of the operation, and we're talking about 30-acre, nearly 30-acre pepper greenhouses here, those loads can be really dealt with quite well with solar and battery and affordably, and you pick up a lot of dynamism with an arrangement like that, generation independence and resilience at large. If you have lights, a smaller sort of demonstration operation that can contribute to those loads, still also effective. And again, I'm biased because we're really interested in the technology. We're really interested in seeing it implemented and built so that we can sort of see how it helps and what can be done to improve how it can help. So that said, happy to answer questions when that time comes, and anxious to learn more with the rest of the work ahead. Thank you.
Thanks, Ruth. Next up, we have Vicki. Yeah.
Yep, over to me. Thanks. I'm Vicki Gagno with the IESO. I work in demand side management with a particular focus on the agricultural sector. Next slide. And taking the learnings from the University of Windsor's project that Ruth was just talking about, we took the learnings on expanding greenhouses through distributed energy resources and worked with some local experts around the opportunities to help support the greenhouse sector in expansion. And we established a greenhouse stream within our retrofit incentive program. Next slide. So the greenhouse stream, which was designed to help support efficient operations within the greenhouse sector includes incentives for LED grow lights, both for vegetable and flower greenhouses, as well as cannabis indoor warehouses, as well as inner lighting, and also incentives for advanced lighting controls to control that lighting. And these incentives are available for both retrofitting existing warehouses as well as newly constructed warehouses. And the incentives for the LED lighting and controls are available for all greenhouses across Ontario. We also added a new pilot offering in the Southwest region that has particular constraints for distributed energy resources for greenhouses in the Southwest region to help demonstrate this technology within this sector. Next slide. So the incentives for the distributed energy resources for greenhouses in the Southwest sector are $1,435 a kilowatt for solar PV and $260 a kilowatt hour for battery storage. And that's up to 50% of the eligible project costs. And the incentive is for systems of at least 50 kilowatts and up to a maximum of a megawatt. Now, the system itself can be larger than a megawatt, and we've had conversations with some growers that are considering systems of up to 5 or 10 megawatts, but the incentive would only be available for up to 1 megawatt. Next slide. And the eligible regions for which the incentive is available are greenhouses that are located in Chatham, Windsor, Sarnia, Windsor, Chatham, Lambton, Sarnia, Windsor, and Essex region with the postal codes that are at the bottom of the slide. Next slide. So the incentive is for a combined system, both PV and battery storage, because the local peak in the area isn't during the day when the sun is shining, as it is in many other parts of the province when the air conditioning load is the highest. But the peak is in the early hours of the morning, particularly in the winter when the grow lights are on in many of the greenhouses. So it's designed to gather the energy from the sun during the day and to store it in the batteries to be used at night or in the early hours of the morning when all the lights are on. We've had some discussion with some growers that were interested just in the PV only, as they could use all of the energy produced from the PV during the day. And that's great on an individual greenhouse basis. However, it wouldn't help the local system peak in the areas. And the reason that Save on Energy is piloting this incentive program is to help manage the local system peak. So it's designed to help generate electricity for on-site use, not injecting into the grid. So the customer is intended to use all of the energy that is generated from the PV system through use of battery storage to use the electricity to help power the lights. And there's another element of eligibility around the location of the PV panels. The forms say that it must be mounted on new or existing building rooftops, like warehouse rooftops. And we've had some questions from growers about the possibility of a ground-mounted system next to the warehouse or the greenhouse. And ground-mounted systems would be considered as long as it's next to a building or in the general vicinity of the greenhouse or warehouse, and as long as it's not on prime agriculture land. Next slide. To apply on the Save on Energy website, the retrofit program, you go to the key documents section, and under the worksheets, there's a specific worksheet for the Southwest region greenhouse solar PV and battery DER worksheet. And this worksheet is a mandatory worksheet. Some of our worksheets are optional worksheets to help a participant calculate incentive. However, in this instance, it's a mandatory worksheet. And the applications, in order to receive an incentive, the application needs to be pre-approved by the end of this December 31st, 2024, and the measures need to be installed and operating by the end of next December 2025. Next slide. And if you need additional support, you can contact the Retrofit Save on Energy delivery agent in the Southwest region at the number or the email on the slide.
Thanks, Vicki. Next up, we have Leon.
Good afternoon, everyone. My name is Leone King, and I work with Energy Storage Canada as our Manager of Communications and Member Relations. And I'm here this afternoon just to give kind of a high-level overview of BESS safety, and we'll have folks follow me who will talk in more detail about some of the specific regulations and policies. So next slide. Oh, and one more. So just a little bit about who we are as Energy Storage Canada. We are the National Trade Association for Energy Storage. We're a not-for-profit and we're founded in 2016. We have nearly 100 members from the east to the west coast, and we're technology agnostic when it comes to energy storage, which means that we support short and long duration of all types and technologies. And we work with the value and supply chain from end to end. So basically the full lifespan of the battery from when it's manufactured and all its multiple components, all the way through to the end of its life and recycling at the end. Next slide. So just to talk a little bit about why we're looking at energy storage as an option so frequently in different grids across the country. And one is that our electricity supply is changing. The types of resources that are providing us with electricity on our grids is changing. We're seeing demand patterns changing in terms of when folks are using most of their energy, when there are lulls in the consumption of energy. And the other piece is that grid operators need additional resources and tools to meet some of these changes that are happening in the demand patterns and the supply of electricity. And the great thing about energy storage is that it can increase the utility and efficiency of existing resources. It can work with any type of resources. So it can work with the resources that are on the grid today, or it can work with the resources that are on the grid in 10 years and 20 years and so on. So the energy storage resources are able to offer a lot of versatility and flexibility. They increase the reliability of a grid, and the more renewable options that you have providing electricity supply on your grid, the more sustainable that your grid is going to be, and energy storage can help support that as well. That also helps to support any of the net zero goals and decarbonization efforts that are happening across the country in different provinces. Next slide, please. So next is what is energy storage? We talk about it a lot, and I think what most folks think about is what we're here to talk about today, which is battery energy storage systems. But energy storage broadly is any technology for a process that captures energy when it's not needed and stores it for later use, eventually discharging it. So it's anything that can hold energy when you've got too much of it and use it later and discharge it back to the grid. A lot of the kind of different technologies that we're seeing fit into these broad categories of chemical, mechanical, thermal, electrical, and industrial. There's even more breakdowns within each of those categories, but these are kind of the general categories that we're seeing. And for today's conversation, looking at batteries, whether they are batteries for EVs or batteries at the grid scale size, we're looking at a chemical type of energy storage. So next slide, we're looking at battery energy storage systems, which is one of the class of energy storage technologies. And it's based on a fundamental level on the same technology as the battery for the phone in your pocket or your laptop. It's classified, as I mentioned, as a type of chemical storage. And currently, lithium ion is the most popular battery chemistry. It has medium to high energy power and density. It's rapidly able to respond. So if there are changes in the grids, something happens unexpectedly, it's able to quickly respond. And it has a mature supply chain, which means that it's easy to deploy quickly, which is important when there are a lot of changes happening all at once in your grid and in your system. There are a lot of other battery chemistries that are being developed, however, an example being zinc or vanadium flow batteries. So the next slide, we're looking at the principal BESS components. So these are the pieces that go into those big containers that you see in all of the images of battery energy storage systems for the grid. They are comprised of a battery management system, which monitors the conditions and functions of the battery cells. We've got the power conversion system, which allows batteries to charge and discharge. Energy management system, which collects and analyzes energy data to manage the full system. So all of the different systems that are included in the battery energy storage system. And then we have the safety systems, which can include temperature controls, HVAC systems, fire control systems. There's a lot of different systems that are included there. And on the next slide, we've just got a couple of images to give you a bit more of a concept of where all of these different pieces might fit within one of these battery energy storage system modules. When you open the containers, these are the kind of pieces that you're going to see in terms of the stacks of battery modules, the battery management system, the power conversion system, all the heating and ventilation and cooling systems. They all are put together a little bit differently. So you might see very different things on the insides of different particular battery containers, but all of these components are going to be in an energy storage system for batteries in one form or another. So on the next slide, we're looking really quickly at just some of the benefits of BESS, which we kind of talked about a little bit, but BESS specifically is able to store electricity from non-emitting sources to make them available when energy production is low or demand is high. And these are especially useful in terms of renewable energy, where you can't control when the sun shines or when the wind blows and you might have excess energy. It's great to be able to store that low cost energy and use it later. It helps to make sure that your grid is running as cleanly as possible and lower your emissions. The other thing that BESS does really well is it optimizes the electricity that's generated. So it can delay high cost infrastructure development in terms of transmission lines and other pieces of energy system assets that would need to be developed instead. It can store low cost energy and save it for later. And it can optimize just all of the systems that are on the grid. For example, if we're looking at gas systems, they often are brought online to deal with high intensity demand through peaker plants, and BESS, if it has a charge of low cost solar energy that's left over from the morning, could put that back into the grid instead of ramping up some of the larger energy systems, which is going to reduce the costs that ratepayers pay. Second is the fast responses to fluctuation in supply and demand. It helps maintain system balance. The aim in any system in North America is to have things coming along at 60 hertz, and BESS has really instantaneous capabilities to be able to help balance out any of those fluctuations and ensure that we're getting a reliable, steady supply of electricity to the asset that we need. It can also provide backup power to ensure the continuity of critical services, so you can have them for when there's blackouts, or just serving as backup power when you need to do updates to other infrastructure. It can provide energy to the grid. So on the next slide, we'll get into one of the most common elements of safety that we hear a lot about at Energy Storage Canada, which are, generally speaking, as diverse as the communities where the assets are installed. Different communities have different concerns, have different thoughts, and all of these installations are going in different places in the community, which changes the way people are thinking about them. But fire safety is one that we hear a lot about. Incidents of fire or thermal runaway, though, are quite rare and becoming rarer. There are a lot of rigorous testing and standards that are being applied to the manufacture and installation of these assets. They're being tested in real world scenarios, and the incidents of fire are becoming less and less across the board as we learn more and more. There are a lot of safety standards for BESS specifically related to fire detection and suppression. There's a lot of different things that can be done both passively and actively to your BESS installation to help prevent fire and help deal with fire in a safe way if it should occur. Some of those things can be some of the different systems that we mentioned earlier. There's a bunch of examples of the preventative measures and systems down below in that blue box, looking at the battery management system we talked about before, thermal imaging, ventilation, fire suppression systems, remote monitoring, the way you design your site, the separation between different cases, having them not be walk-in. There's a lot of different ways that you can look at the design and the manufacture of the assets to ensure that they are as safe as possible. That's absolutely the goal of everybody along the supply chain, starting from when they're beginning the manufacture to getting those assets to where they're going to go and contribute to the grid. And each installation also develops an emergency response plan with local first responders. So the incidence of these happening is pretty low. There are a lot of high standards that are tested and proven to try and ensure the safety. There's a lot of passive and active systems in each BESS installation, and installations are working with emergency response folks to ensure that they have the best plan in place. So on the next slide, we'll look a little bit at specifically Canada. So last year, we were able to do a study with an engineering consulting firm called BBA, and they asked 4 of the leading original equipment manufacturers here in Canada and North America whether they've had any incidents of thermal runaway, how much of a risk this is, how much they're seeing this. And of the 4, only 1 had encountered an incident of thermal runaway, and it was related to a much older product than what would typically be seen, and definitely than what would be currently installed and future installed. There are and have been batteries already installed in Canada in its electricity system, so some of these assets could be as much as 10, 15, 20 years old. And the same person who identified that there had seen one with an old product said that they've had no incidents with the current products that they're working with. And all 4 described the risk of thermal runaway as extremely low, and that the low risk in combination with the additional mitigation measures, such as the battery management systems and all those fire suppression systems we talked about, definitely outweighed the, ensured that the benefits to the communities far outweighed the risks. On the next slide, we've also had the chance to talk to a lot of emergency first responders, and they obviously are working with and get the details of the emergency response plan for each site. They're shared with and often developed in consultation with emergency response providers in a locality, wherever this asset is going to be. And our discussions with first responders, such as the Ontario Association of Fire Chiefs, indicates that they feel well equipped to manage an emergency response at any BESS site, that they feel like they have the tools that they need and the knowledge that they need to safely respond to any type of incident should it occur at a BESS site. And this last slide is looking at some of the broader environmental concerns. As I mentioned, fire is one of the safety concerns that we hear about quite a lot. That has a lot to do with the media coverage on that point. But in terms of our environmental concerns, a lot of folks are concerned about how much space these assets are going to take up, what impact, if any, on the soil, the air, those different things. So compared to other non-emitting assets, BESS have a pretty small geographical footprint. They're in the containers, they're in a particular specific allotted space, and they don't take up a whole lot of space. You can fit a lot of energy storage in a very small space. They can also be installed with minimal impact on the soil, if that's a concern. They can be housed on skids and then just pulled out at the end of the asset's life cycle, meaning that you don't have to dig real down deep into the ground. There's not permanent infrastructure in terms of cement and things like that in great quantity. In terms of toxicity and toxic gases, which is something that we sometimes hear about as an environmental concern related to BESS, the gases that are released in the event of a fire have been so far in all of the extensive testing that's been done, not indicated to be present at a significant enough level to provide harm. The other concern related to toxicity is usually the water table. Obviously, we want folks, when these are being cited, to ensure that they're doing all of the proper planning, environmental assessments, stakeholder engagements, and those sorts of things first. But second, we're looking at the water table as a concern. Safety authorities actually recommend not using water for best fires. So there's not a likelihood of a large quantity of water being used and interacting with the BESS system in any way. And the last thing that we hear about related to environmental concerns is typically mineral waste. So all of the minerals that are going into the development of these assets, what happens when the life cycle is over? And we're already working with recycling companies who are operating here in Canada. Some of them are Canada-based, Canada born, and they're working on repurposing all of the different batteries. There's also a couple of great institutions on the East Coast that are doing a lot of battery research, particularly with EVs, but all of them are looking into ways that we can repurpose and recycle these different assets. And this last slide that I have to share with you is just the map that we share in terms of where we already have some of these systems operating. Alberta is definitely leading in terms of where those assets are currently installed, but Ontario is quickly, with their current procurement, ramping up to match and exceed it. So there are a lot of different installations already in Canada that are operating and operating safely, and a lot of different folks who have the expertise and the knowledge to ensure that that continues in Canada. And with that, I will pass it off to the next presenter.
Thank you. My name is Andrew Pacha. I'm with Underwriter Laboratories of Canada. I participate on the Canadian Electrical Code Part 1 as a voting member. I also participate on Section 64 of the Canadian Electrical Code as a voting member. And Section 64 of the code deals with renewable energy, energy storage systems, and other generation types. So next slide, please. I just want to do a little overview of the history of energy storage system rules in the Canadian Electrical Code. Up until the 2021 publication of the Electrical Code, there really were no specific rules for energy storage systems. In the publication of the 2021 code in January of 2021, there were new definitions added for energy storage systems. There was a new 64918 series of rules specific to the installation of energy storage systems. And one of the things with that is that in the 2021 version of the code, requirements for energy storage systems, regardless of energy storage system type and or location, whether it was a residential application or a non-residential application, were somewhat grouped together in one series of rules, which made it somewhat difficult for code users and installers to interpret, for one. But it also was seen as a bit of a burden to industry because we went from no rules in the 2018 edition of the code, or no specific rules, I should say, to having rules that were quite stringent, to be honest, and it was seen as a burden. Now, fast forward a little bit, there was a working group that was formed in the summer of 2021 to look at these rules that were published. And to see what we could do to, more align with the product standard, which is UL 9540, other publications that are out there in industry, such as NFPA 855. And as a result, we completed a proposal that was balloted and passed in June of 2023. And this new ballot or new proposal includes revised definitions for field assembled and self-contained energy storage systems. The 64918 series of rules that I originally mentioned was in the 2021 code, was completely rewritten. A new section 64-1000, which is regarding energy storage systems in general. And to Leon's point in her previous conversation, she mentioned about energy storage systems could be different types of technology, not just batteries. So this general section would apply to all energy storage system types. And then we have a new 64-1100 series of rules, which is specific to residential applications. And as I mentioned, the rules as written in the 2024 code, I should say, that was just published in March of 2024, are based primarily on ANSI CAN UL 9540, 3rd edition, and the publication of NFPA 855. Next slide, please. With that said, one of the things, as I mentioned, there were some changes to definitions, and I won't go through all the definitions, but what you're seeing here on the screen is actually an Appendix B note. Appendix B in the Canadian Electrical Code is an informative section of the code. But this particular note speaks about field assembled energy storage systems. And I wanted to focus on this just for a moment because, as mentioned, an energy storage system could comprise of multiple pieces of equipment to form the overall energy storage system. And this equipment may include batteries, protection, control, power conversion, charge control, and fire detection, as was mentioned in the previous presentation. And this definition also applies to systems approved at a manufacturer's facility prior to field assembly, and applies to field assembled systems that require approval in the field. And the reason I want to focus on this, in the previous presentation, you noticed there was some energy storage system images of containers. And for a container application, that may show up on site in one of two ways. It may be fully assembled, meaning that the batteries, inverters, charge controllers, and other associated equipment are all inclusive in the container, and that's overall is an approved piece of equipment. Or it may show up in multiple pieces because of the physical size of it, the shipping weight, especially of the batteries, and then it gets assembled on site in the field. In that case there, the original certification of that product would still be intact. The installer of the energy storage system is required to follow the manufacturer's installation instructions when reassembling that energy storage system. Now, alternatively, it could be such that an energy storage system is built on site by an installer using batteries, inverters, charge controllers, and other associated equipment that hasn't yet received an overall approval. If that is the case, then it is still required to be approved. It'd probably go through what's called a field evaluation based on an SPE 1000 model code. And it also would be, of course, inspected by the local inspection authorities. Next slide, please. So this next rule that you see here on the screen is also synonymous with equipment being approved. And the reason I wanted to focus on a few things that are in my presentation is I know this overall webinar today is about the safety of energy storage systems. And from a code perspective and a standard perspective, these things are in place to try to ensure the safety of the installation and also the safety of the products that are being installed. This new rule 64-1002, which speaks about installation requirements for energy storage systems, specifically says now that an energy storage system has to be approved. And energy storage system utilizing batteries shall comply with Rule 2-024. I know this isn't showing here on the screen, but Rule 2-024 provides direction to code users and installers, designers, that an energy storage system must follow certain criteria to become approved, which may mean full certification, as I mentioned, where the energy storage system is certified off-site, and then it shows up and it's either reassembled or it's already self-contained in a container, or it's built in the field and it still is required to be approved. There's also an Appendix B note to this particular rule as well that says electrical equipment used in electrical installations within the jurisdiction of the inspection department shall be approved and shall be of a kind or type rating approved for the specific purpose for which it is to be employed. Okay, next slide, please. Lastly, the one thing I'll speak about is the actual standard for safety for energy storage systems and equipment. So ANSI CAN UL 9540 2023. This is the most recent edition of this particular standard. It's the 3rd edition. Was published, I think, February of 2023. One thing to note with this is that with any standard, there's dates when it actually becomes effective. So, and it's sometimes based on adoption of the code as well. And so this particular standard, even though it's published, may have requirements that are ahead of where the applicable standards are today, which would be the second edition of 9540. So these requirements cover an energy storage system that is intended to receive and store energy in some form so that the energy storage system can provide electrical energy to loads or to a local area electrical power system. Just 1 second, sorry, I have multiple screens. This standard also applies to electrochemical, chemical, mechanical, and thermal energy storage systems. And an ESS shall consist of at least an energy storage system function and an energy storage protective function. The standard also covers energy storage systems for stationary indoor and outdoor installations, and also covers mobile energy storage systems, which is something that's actually becoming more commonplace. And it includes requirements for energy storage system used in both residential and non-residential use applications. So in summary, I just wanted to really point out, how the codes and standards are aligned together to provide a safe installation, and also to provide guidance for certification organizations and inspection organizations to evaluate the product to make sure that the overall energy storage system itself from an assembly is safe. And from that, I will pass it over to the next presenter.
Good afternoon. My name is Tatiana Dinic. I'm a code engineer at Electrical Safety Authority. I'm here to provide you a quick introduction who Electrical Safety Authority is and our role with the whole safety system. So today it will be a really very quick overview. Electrical Safety Authority mandate, regulations that we oversee, and Ontario Electrical Safety Code as a basic book for the safety of electrical installations, and a few rules that are important before starting any electrical installations, including ESS and PV installation. I hope that you know who we are. Electrical Safety Authority is a delegated administrative authority responsible for the administration of Part 8 of the Electricity Act, and we are also enforcing some corresponding regulations. Next slide, yes. There are 5 regulations that we are enforcing. The first one that was introduced is Ontario Electrical Safety Code. And Ontario Electrical Safety Code sets some basic principle how to do electrical work. So this code provides basic electrical safety, licensing of electrical contractors and master electricians. This regulation provides sets of requirements for businesses and certain people who can do electrical work. So this is the regulation related to a licensed electrical contractor. Electrical distribution safety is a little bit different regulation compared with the Ontario Electrical Safety Code, that it's a subjective regulation, so these are rules. Electrical distribution safety regulation is objective-based regulation and actually provides and oversees and sets the requirements for local distribution companies. Next two are electrical product safety. Electrical Safety Authority is responsible for a product approval. Andrew talked a little bit about the approval of energy storage systems. So this regulation deals about approval, pre-market approval requirements for all electrical products, also covers safety of commercial and industrial products. And Electrical Safety Authority does not have a jurisdiction over safety of consumer products. This is something that Health Canada does. And the latest regulation is about administrative penalties. It has been added to our mandate just a year ago. Basically sets out how ESA can issue administrative penalties for non-compliant actions. Ontario Electrical Safety Code. This is a book that Andrew has been talking about. Our Ontario Electrical Safety Code consists of the Canadian Electrical Code plus specific Ontario amendments. Majority of the Ontario amendments are in the administrative part of the code book, is basically how ESA handles these electrical inspections and safety of the installations. Currently, we are working on a 28th edition of the code, which is 2021 version. We are now planning for a new code, 2024, and new Ontario Electrical Safety Code 2024 that will include these updated rules for energy storage systems will come in effect in Ontario in May of 2025. But we already published a bulletin that deals with residential ESS installation and accepted some of the changes in a Canadian code. Next slide. Few important rules before you start any electrical work. It's requirements for notification, or this rule used to be known as a permit required. So every contractor, and the contractor per our definition is a licensed electrical contractor or a homeowner, is required to file a notification for any work prior to starting the work, or if this is not possible, 48 hours before, after the work has been started. That's the first thing that you need to remember. Second thing is requirements for plan review. We have a rule that for installations that are larger, for three-phase services more than 400 amps, single-phase service more than 600 amp, and for any energy storage installations or any renewable installations that are more than 10 kilowatt, you will need to apply for a plan review. I think plan review is actually a very good asset to the industry, because when designs are brought to plan review, then our plan reviewers will review design based on a code requirements, provide a comments, and designer will be able to address these comments prior to starting the work and avoid the expenses that could come and would come later if there was no plan review comments. And the last rule that I want to talk about is rule about approval. We have a rule that all electrical products are required to be approved. So any electrical product is required to be approved that it's used, advertised, displayed, sold, or disposed. This is our Ontario rule. There is a similar rule in a Canadian code, and approval means that third party has to verify safety, that the product has met the minimum safety standard requirements. Andrew has talked for energy storage system, the minimum safety requirements are in UL Standard 9540. UL Standard 9540 is also a Canadian standard, so every energy storage system is required to be approved. In PV installations, almost every single part has applicable standard and requires approval. Next slide. So this is a list of the agency that can do approval, that are a certification of the product. You can see there is lots of recognized agency. In addition to CSA, UL, or Intertek, there are some others, and this list is on ESA website. So any of these agency, based on their accreditation, can do a product certification. And the last slide shows the list of the field evaluation agency. This is another way how you can get the product approved. This is meant for a small number of products. There is a list of the acceptable field evaluation agency. These are their markings. So if the product is field evaluated, that product is also considered to be approved. If energy storage systems are field evaluated, then field evaluation needs to consider the requirements of UL 9540 standard, and that will be considered as approved energy storage system. Thank you, and maybe next presenter.
Okay, thank you. Hello, everyone. Good afternoon. My name is Nick Bunsick. I'm a senior accounting executive with the Advanced Manufacturing Branch at the Ministry of Ministry of Economic Development, Job Creation and Trade. That's a little bit backwards there, but I'm here today to talk to you a little bit about some examples of behind-the-meter energy storage. We thought it'd be a good idea to show how broadly used these technologies are. Looking here to the first example, we have an energy storage system with Berry Global International. Berry Global is a manufacturer and marketer of plastic packaging products. The partners in this project are Enel North America. Enel is an Italian company via its Enel Energy Services division. The project itself involved the purchase and installation of battery energy storage systems at Berry Global's 4 locations in Ontario, in Belleville, Orillia, North Bay, and GTA. 4 behind-the-meter lithium-ion battery installations totaling 5 megawatts of output and 5 megawatts of output capacity and 10 megawatt hours of storage capacity. Enel operates the systems and provides peak prediction services and has enrolled the batteries in ISO's demand response program. So a number of benefits for Berry Global. There's the financial benefit of participating in the demand response program under NLX. So they are participating in virtual hourly demand response and are generating some revenue from this. There's peak shaving to reduce global adjustment charges, and they are forecasting 20 to 30% energy bill savings annually. Next slide. Okay, so this is a unique case study for you. It's quite different than most of the situations we see, such as Berry Global, where we're looking at a lot of the time they're driven by global adjustment. I think it's called GA busting is the term they use, where they're trying to reduce their cost regarding global adjustment because it's a significant portion of their energy bill. This one is a unique example because we're looking at a school, and the drivers behind this are slightly different. In this case, they're looking to be a leader in energy efficiency and achieving net zero. So we have John Paul II Catholic Secondary School in London, Ontario. The project partners are the London District Catholic School Board and Amoresco Incorporated. And in the project, Amoresco oversaw the installation of a wide variety of technologies inside the school and outside the school aimed at achieving net zero, such as advanced geothermal heating and cooling. The installation of 2,700 solar panels as covered carports, 4 electric vehicle charging stations, 1 megawatt output capacity, 2.2 megawatt hour, 2.2 megawatt hour storage capacity battery energy storage system. Also participating in ISO's demand response program, essentially setting up a microgrid with integrated building controls. So here, if you look at this picture, you can see the school in the center. You can see the arrays of solar panels to the right and the left of the school. And if you look at those 3 little white dots, I've blown up the picture here for you. That is that's the energy storage system right there. It's a Tesla batteries located just right across from the main school building. So some benefits to the school: there's no upfront capex. It was contracted under a 25-year energy as a service agreement with Amoresco. It stabilized the energy costs for the school and avoided carbon taxes over the long term via fuel switching. There is a big educational component to this project for students to be able to point to these technologies and point to the fact that this is trying to achieve net zero. We're looking at educating the next generation workforce. And there are also the bragging rights that this is North America's first carbon neutral retrofitted K-12 facility. Next slide. The third and final example I have for you here today is StackTech. It's an AI-enabled battery storage system. Project partners include StackTech, in Brampton, Ontario. They're a global provider of integrated plastic tooling solutions for the injection molding industry. And STEM Incorporated, which is a California-based AI-driven clean technology solutions provider. So the project itself was the installation of a STEM 1 megawatt, 2 megawatt hour battery energy storage system installed at the StackTech facility. And the BESS leverages STEM's Athena software, which predicts GA coincident peaks and autonomously directs the energy storage system to discharge and reduce the utility load when required. So benefits for StackTech. Prior to the STEM installation, they were spending roughly 60% of their facility's electrical bill on GA, or global adjustment charges, and the project resulted in more predictable monthly energy bills and dramatic savings for StackTech. So I just wanted to, while we're talking about GA busting, I just wanted to bring your attention to a study that was done by, or a survey that was done by ISO in 2021, September 2021, where they surveyed 198, they surveyed the Industrial Conservation Initiative with regards to distributed energy resources, and there were some significant numbers that came out of that. Specifically, they found that there was 188 megawatts of battery energy storage installed across the province through 79 installations. Now those numbers are a little bit dated now. This is 2021, but you can see that that's a significant volume of battery energy storage specifically installed in Ontario across a wide range of users. 82% of those installations were using a third-party peak prediction service. So, for example, STEM, and 55% of those were participating in demand response auctions. So there are quite a bit of cost savings driving this global adjustment, but also the revenue generation that comes from participating in these demand response programs. So maybe I'll just stop there and pass it back to Megan.
Thanks, Nick. And thank you to all of our speakers for your great contributions today. I think that will bring us into our Q&A session. I see we have a few questions in the chat. Maybe we can run this through a series of raised hands, and we'll take the questions one at a time if you want to unmute yourself. Otherwise, I will start reading out of the chat. Vicki, there were quite a few questions about
Yeah, I was just about to
systems.
jump in. Yes, there were several questions about ground mount systems. And so the intention of the program, we originally wanted the PV panels to be roof mounted on a warehouse, either a newly constructed one or an existing one. And through conversations with our colleagues at OMAFRA, we realized that there was often a lot of space in and around the general greenhouse land that is not currently productive land, but could be ideally used for photovoltaics, ground mount photovoltaics. And that could include the grass buffer land between the greenhouse and the next plot of land for biosecurity issues. It could include the roadway coming in. It could include, spaces between various buildings on the land. And those would all be considered, including the storm water ponds that are there. So the purpose is just not to take out class 1 or 2 productive agriculture land. And we do understand that there is a potential value for that as well through agrivoltaics, and we're in good conversations with the folks at agrivoltaics, and there are things to explore there, but that's not what this is intended for. The intention for this was originally to be roof mount. However, we would consider the grassy areas, the stormwater pond areas, any of the general land in the general vicinity of the warehouses or greenhouses that's not taking out productive class 1 and 2 agriculture land.
Thanks, Vicky. I hope that answers everybody's questions, but like we said, we will be sharing the slides later and the contact information is linked here for all of you as well. Perhaps this is a good question for Leon. In the case of a fire, any difficulty with recovery costs, or what about insurance products to cover the recovery process?
Sure. So in terms of insurance, it's a lot like any other major asset infrastructure piece where there are a really big range of pieces that are being considered by the insurer, such as site selection, equipment, contractual obligations, what risks it was exposed to, operations and maintenance plans, the reputation of the EPC that's developing it, any of the plans around the site, the first responder plan, the emergency response plan. All of those different pieces are factored in by an insurer when they insure one of these BESS assets. So it's like any other major infrastructure project in that if you do your due diligence and put all of these pieces in place and work with your insurer to outline that all of these pieces have been put in place in advance, that insurers are willing to work with owners and operators just as they do with any other major infrastructure pieces.
Interesting question here from Philip Dick, also not related to greenhouse storage, but electrical fencing. Phil, did you want to come and ask the question yourself?
Sure. And this is not related to greenhouses. It's in the livestock sector primarily, where electrification is being used to replace old wire fences in some instances. In other instances, they're additional. But I was just wondering about the insurance and any kind of planning requirement there. I think the question was answered because these tend to be single phase and they're way less than 400 amps. So, and it just looks to me like they may be outside of the planning requirement, but based on the type of equipment, there could be issues around the safety of those systems.
So that's a good question, Phil. And I think that's something that's better for the LDCs to respond to. And I think that's something that we can explore. We're in conversations with them about these PV battery storage and sizes and their input as well. And so when we're having conversations with them about these offerings, it's certainly something that we can ask about. If you know of any specific project in terms of sizes and whatnot, it's sometimes helpful to get a response if we're reacting to a specific project. But I've not heard of it been an issue with anyone. So I don't want to answer that. I think that's better for the LDC to respond to.
Yeah, it's just it's a low level energy draw, but it is an energy draw, and really the greenhouse conversation isn't a place to bring it up. But I had the question.
Nevertheless, it's an agriculture energy issue, and we'll see if we can get an answer for you.
Thanks.
I think Tatiana has something to contribute.
Yes, well, as I said, every electrical product requires approval. I would probably love to have more information, and actually our local technical advisor should have more information about design prior to saying, there is applicable standard for this installation. We need more details to understand how the system is built and are there applicable safety standards, or is the only option field evaluation? But as a general statement, this is electrical product and product should be approved.
Yeah, and most of this, I've seen projects in the States. The projects I've seen here tended to be fly under the radar.
Thanks, everybody. I see a couple people are starting to drop off. So before everybody does go, if you don't have questions, we do have a survey prepared. You can access it through this QR code through your phone's camera app, or just go to menti.com and enter in the code that's in bold there. And we're really just looking for some feedback on today's session, as well as what you might want to hear about in future sessions so we can inform our planning. Question about the permitting process just came in here, specifically Kingston, Kingsville, and Leamington areas. Do the government land planners need to be involved in the approval process before submitting a funding application? Vicki, do you know anything about that?
So I'm not quite sure who the government you are referring to. They're the local distribution company, which in this area often is Hydro One, but it could be one of the other ones, should be informed of it. And I don't know if a CIA connection impact assessment needs to be applied for or not. That you would need to have a conversation with your local distribution company regarding the size of the application. You don't need to have all of those approvals to apply for the retrofit DER incentive application. In fact, you might want to see if you get approved for funding first before you would go to the LDC and then get all of their permits, because sometimes that can take a longer period of time. So you don't have to get a connection impact assessment done by the LDC first before you come to us. You will likely want to come to us first, and we're in conversations with them in terms of as we move forward, how to exchange information and the whole approval process. This is a new pilot initiative for us, and so we're working through all of those for the first time as well.
Thanks. I think specifically government was maybe municipalities.
So very good point about government and municipalities. And that was another reason why we originally suggested that the system needed to be roof mounted, because then you don't have as many issues with local approvals. So you do need to have your local approvals, your LDC approvals, all of those things do need to be approved before you move forward. And we thought that roof mount would be easier, but if it's ground mount, you do need to have local, municipal, or regional municipality approvals.
Great, thank you. I had seen a hand up, but I think it's gone down.
Yeah, it's Gary Ronsky. That was me that had a hand up.
Please go ahead.
I work for Clear Result for a year now, and I've been looking for directions on how to get this kind of program into our emergency services, like backup cell service plan, and nursing station in a remote area, First Nation. Because we had a few contractors that came up and installed a solar panel system on a water plant, but they never showed the operators on how to maintain it. And this was like about a decade ago. And with the same thing with nursing station, there's a backup battery in a garage where it's not being used as it should be, but it's still sitting there.
Okay. So the question is really, will the funding pilot potentially be extended to other regions?
Yep.
Maybe that's a question for Vicki again.
This pilot is just for greenhouses and only in the Southwest region because of the particular constraints. I think we are looking at all options as we move forward in terms of support that's needed as as we're moving forward with planning. But at this time, I'm getting a note from a colleague saying the energy support programs may be a good option. Through the IESO has energy support programs specifically for First Nations communities. That does include both capacity building for local people on the ground, as well as technology implementation on expanding energy installations in the area. So the energy support program through the IESO may be a good area to get both funding for equipment, but also for capacity building to train local folks on the ground to make sure that they're able to use the equipment properly.
Thank you. If we have a link that we can share. Oh, great, Monica. Thank you. Any more questions from the audience? Yeah, it looks like perhaps not. I'm just going to take us through a couple more things. Quick reminder, please do complete the survey if you're able. It's only about 5 questions. It shouldn't take very long. Today's session was also brought to you by the ISO Save on Energy Training and Support Program. So we often run events and we produce tools and resources which are available on the Save on Energy webpage. There's a link here for that. We have a live events calendar. All of these sessions are offered at no cost. You can sign up for our monthly bulletin and maybe just keep an eye out for things that might be of interest to you. And we also provide virtual one-on-one coaching to help organizations manage their energy resources more effectively. And to close it off, just a big thank you to all of our guest speakers today and to an engaging audience. This final QR code is to sign up for Save on Energy's quarterly business newsletter for up-to-date program information.
I think we're okay to close now, right, Megan? Okay, perfect. Thank you so much, especially to all the speakers again. All the contact information is in the presentations as we discussed, and we may reach out to you for any follow-up questions. I appreciate your time.
Thank you.
Thanks.
Take care.
Thank you.
Bye now.
Everyone.